Oops. I think I just did that in the wrong order. All right, well, I'm back sharing my screen where I have the Go code I was working on earlier. I had an issue in one of my tests where I was calling my CLI in this nice little wrapper where I'm passing the arguments that I want to test out to make sure that the CLI is doing the plumbing that I expect it to do. But it wasn't running. It turns out that I needed to add another line of execution here. Since I'm not using OS args, I'm passing them the args. I needed to add an extra line of execution to say like actually run the context of the CLI that you figured out based on the arguments. Other than that, all my tests are passing at the moment. And I have task here telling me my Golang CI lint is good. I have my import test and builder test telling me I have inserted everything into the database. This is great. I'm going to make a commit here, actually, and make sure I don't have anything in there that I don't need. I think I've added everything in my git ignore that I don't want. And I'm just going to say I'm not really good at writing git commit messages. Some people are very methodical about it. I'm not. When it's only me, I have a pretty good idea of what my code is and everything. I use Git at this point as a really large undo button. So my messages are sometimes not that large. For this, I'm just going to say initial plumbing for importing nodes, ways, and relations into SQLite DB. And that's true. If I actually do a go run and do -h, we should see build. So this error message right here, I know why it exists in the sense of it's a, since this is CGO, the library I'm using to process all the OSM files is using not G. Here, I can. It's better to show than tell. I'm trying to do this from memory, and obviously it's not working. If I go here, and I go here, and I go here, and I go here, and I search for Datadog. Okay, there we go. Use the CGO zlib. This is just messages from the flag set for the zlib compilation. It doesn't break anything, but I haven't made a PR to try to fix it for them. So let's try to run this against a file that isn't a fixture that I downloaded as like a small little fixture. So let's actually do build.osm, and I happen to have a bunch of them already downloaded. Downloads. There we go. And let's output a test database. db test db. It's doing stuff, but we don't have any indication that it's doing stuff. I don't like it when things are happening and you have no indication of what's happening. I mean, we got some log messages there, but we don't know how long this is going to take or not. Well, how about this? Let's use a progress bar. I'm going to clean up the test databases that we have there for a second. And I'm going to do something just for my own benefit, which is in the git ignore. I'm going to add star.db star. As long as I use a convention of db with SQLite, I think that will ignore everything, so I'll never accidentally check in a very large file. Let's add a progress bar. I'm not going to write a test for this, mainly because it's a visual indication for the user, and I don't really really have a good way of testing this at the moment. But let's look for a progress bar. Let's go here. Let's move the screen over here. Let's look for Golang progress bars. A really basic thread. Safe progress bar. What does it look like? I mean, that is true. That is a progress bar. So how do I do the progress bar on this? Because in my importer, when you do the scanning of an object, you don't actually have information ahead of time of how many objects there are. This is something I know about the OSM PBF scanning. There's no metadata about how many objects there are. You actually have to like scan through the file to count things. So it's going to be hard to have a progress bar to count things if you don't know how many things you have. Well, what do we have on scanner that we can use? Scanner, skip filter, fully scanned bytes. What does that do? Fully scanned bytes returns the number of bytes that have been read and fully scanned. Oh, okay. So if we know the size of the file and how many bytes have been scanned, we might be able to write a progress bar. Hey! Okay, so can we do bytes here? Default bytes, content length, downloading. This does look like a progress bar. So this progress bar pretends to be a reader. Well, we don't have a reader. No length. Progress length is a spinner. Any bar with length -1 converted to a spinner. Okay, well, let's try this out. Let's do go get. I don't know why that's not. Okay. Let's do progress bar with some bytes. We know. Do we know the size of the file? We don't know the size of the file, but that's something we can find out. OS file info, right? I feel it's like a thing. This is. I need files. I need stat. Yeah, because then I pass it a file name. Yeah, there we go. I.file name. Okay. Oops. Sorry, didn't mean to jump up there. Fat fingered it. Stat. Error, if error not equal to nil. I always got in the habit of just returning helpful error messages. It's tedious, but cannot stat the OSM PBF file. I just noticed up here, this says PBF. Okay, so we have stat size. Okay, and then we can load up the progress bar here. Yeah, okay. All right, we load that, and it does not like that because it's N64 and it expects max byte 64. This is a func. Oh, okay, yeah. Importing. Okay, so we have a bar. And can we set the bar to something? Add, change, clear, close, exit, get max, is finish, reset, set. Set. Okay, so if I set it to scanner fully max, there we go. I don't really care about the error that comes back from here. Okay. So, I think there was. How does the bar know when it's done? Bar close? There is a bar close. There's also a bar finish. A bar finish and bar close, bar exit. Exit will exit the bar to keep current state. Finish, reset. What does close do then? Finish. Oh, it just calls. All right. Well, it doesn't matter then. Does it return error? Potentially. Don't care about the errors on the progress bar. Okay. So, hey, look at that. Does not seem to be going that fast, though. For a 49 megabyte file, it's going to take 20 minutes. Well, I don't want you to sit here through that. So I'd say our progress bar is working at the moment. It's not fluctuating or anything. It is increasing, and we see the numbers getting bigger. So let's do a task real quick. Aha. Cyclomatic. All right. So all these Golang CI errors at the moment that are based on like the length or the complexity, I'm just going to ignore for now. Those are opportunities to refactor, but I'm not at a refactoring state right now. Okay, so we can see the progress bar appearing in our tests. Good. Cool. Is there a way to make the progress bar just disappear when it's done? Yeah. You know what? Doesn't matter. That's fine. Okay, cool, great. Add progress bar to import. So I'm going to push that up. This is a private repo, so you won't be able to see the code, sorry. Mainly just for my development. I want to share the development, but the code, the final code is for me to use. So that's pretty slow for a 40 megabyte file. I'm not alluding to anything, but I do know some ways to make this go a little faster. So since we have a benchmark, which was not that one, it was up here. 49, it was going to take, we saw, let's say 20 minutes to import that 49 megabyte file. So let's try to make it go a little faster. We have our test suite. This is something I was saying earlier in a previous stream, that I wanted to have a test suite of things that I knew that worked. And then as my test coverage would be the way I know if I'm doing anything for optimization improvements if I break something, right? So let's just think about that for a second. In my test, I'm kind of just doing a count right here. Can I do any sort of integrity checks to make sure things are working as expected? So in our importer test, I'm going to make this a little bigger. We don't need the web browser anymore. I'm going to use my importer test for a second. So we know from the file that we're importing that we'll have 290 nodes, 44 ways, 5 relations. So this is just a count of all that combined, but we could actually just do this count from the database too. So let's add that. So let's just do result. I'm just going to count this. Count where OSM type equals node. And our result should be 290. We know that should appear in the database. So if I do can go watch -r. I don't know why watch doesn't run those databases. So if I hit enter, it should. Okay, there we go. Okay, cool. I'll fix that output at some point too, but okay. So we know this is working. So let's just do that coverage real quick. Way equals 44. Nope. And then we can do 49. Aha. We have a failing test because it's not working. that's okay because when I copy and pasted code, I didn't change this to be relation. And when I copy and pasted code, did I just change the wrong one? I think I just changed the wrong one. I did. I got it. Cool. You know, how about I do this? I'm gonna split this task. Just make sure the goal enter and everything. It's gonna run the test again. I know. It's all right. So I have it showing the coverage, but I'm not really interested in how much coverage there actually is. It's a good metric to see. I don't let it limit my development. It's more of if I see it kind of leaning towards some way, I'm like, ah. But if I try to strive for 100%, the 100% metric coverage in Go, I think, is kind of futile because of the way error handling is happening in Go, where you do if error equals not equal to nil, return something. So the Go linter I have literally enforces me, if I'm not actually doing something with something that returns an error explicitly, it actually would explode. So here, I can show you for a second. So, you know, in my progress bar that I had in the importer. So I ignored the error here. So if I run my no task again, it should complain being like, the error's not checked. I don't care about the error from here. I do care from the error about some of the things that I program, but for a progress bar, if I can't display anything, it should not stop my program. Cool. So all our tests passing, I do this again, just make sure I reverted back to the right way. Cool. Let's, so we've already had the progress bar. This was related to the counts. Fix, add count coverage for the items expected in the database. So, you know, we could also say that we're not actually making assertions on how the data should be formed in the database. Formed in the sense of like a node should have min lat, min long. Ways might have relationships to nodes. Relations might have actually relationships to ways and nodes. I'm going to be honest. This sample PBF file I found randomly on the internet. I literally searched for example OSM PBF file just to have something that wasn't a 40 megabyte file checked into my GitHub repo. I think what I might do is for my builder, let's try to do some optimizations first. Let's see how it works with that smaller data set that I have, because I have a 40 megabyte one, a 600 megabyte one, and like a 9 gigabyte one. Let's try it with the 40 megabyte one. Let's see if we can make that faster so we can actually do some testing against it. Let's explore it with the SQLite CLI, see if the data's in there. And then maybe what we can do is actually have the builder do assertions on the data that it's inserted into the database for us, not as a test, but actually like asserts for data integrity of the thing that it built, right? Yeah, I think that's a good idea. Yeah, let's do that first. Okay, so it's slow, right? We know this is slow. So if I run this again, Oh, yeah. It's slow. It's going 30 kilobytes a second. So if we go back to Builder here, one thing we can learn about SQLite 3 is that every time you do an execute, it's doing something in a transaction, which isn't a bad thing. You know, a transaction in SQL, begin and commit. It's not a bad thing. The only issue is that it adds overhead. So the first thing we can do is perhaps we can just do small optimizations and see if they give us any benefit. I'm thinking here just for our SQL, let's do a prepared statement. So we have an insert statement that is unique for nodes and then the same for way and relation, right? OSM ID. But the only reason it's unique is because we don't include these values. Well, we could fix that. We could just make a prepared statement that says insert all these values, and every time we do it for way and relation, we just set those values to null in the database, nil from Golang. So let's create a prepared statement. I'm just going to call it insert error. We're going to do client prepare. I'm going to take this one just because I like it. If error not equal, as I said, just habit now, could not create prepared statement for insert. And now we can just update these. Just use that. So this disappears. And I can just say insert execute all these things. So let's just try it for this one right now. So if I do, I can go watch -r. I know it doesn't do this immediately. All the tests should pass. Okay, perfect. So let's do it for ways. So let's get rid of this. We're just going to do insert execute. And it needs more. So just looking at line number 79 above, 1, 2, 3, 4. It's just, so I'm just going to do nil, 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 nil. And now the test should pass. E. And then we'll do it for relations. Or we can do insert exec and do nil, 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 nil. So I'm going to take our command. Well, here. Let's just see if it's any faster. Nope. You know what? I'm going to also just do this. Remove test.db star. Because there's the journal file there too, which is an artifact of SQLite if you're using wall mode. Look it up. I'm not going to explain that. But is it any faster? It's above 30 kilobits, but it's like being on a 56K modem back in the day in middle school here. So it's not a bad thing that we did though. Let's on our test pass. Okay, so let's keep that. Use prepared statement for insert. So what else can we do here? As I said, I've done some of this optimization already, so I'm just breaking it down into steps for the sake of the video. So I don't want you to think that I'm like making this off the top of my head, because there are patterns here to do optimizations. The TLDR is I know I can get this to be megabytes per second, not just kilobits per second here. One of the things that actually does take a while is this marshalling of JSON. It isn't fast, right? It's good, it's just not fast. There's a lot of work that needs to be done into in Go called reflection, but introspection into the object that you pass in to generate a JSON. Well, we know what this is. It's a map string string. JSON, marshalling a JSON map string string and creating our own function should be pretty easy to do. Like, oops, not what I meant. There we go. Let's just call marshal tags. Gets tags, map string string. It returns a string. And let's just do payload equals this. And what we can do is if length of tags equals 0, just return empty hash. Otherwise, we're gonna have a payload here. We're gonna have a plus equals here, and we're gonna turn payload. So, we should write a test for this. Because SQLite doesn't do a good job of data integrity of JSON that you're inserting. It's not until you actually try to consume the JSON with a query that it goes, oh, that JSON's not valid. It doesn't actually do validation on the insertion of JSON. So we're gonna write some tests for this. So how about we actually just create a whole new thing? We're just, I'm just gonna create a whole section here called Marshall. Create something here called tags. And in Marshall, let's just do Ginkgo bootstrap. Ginkgo generate tags. So let's say when it returns an empty object when there are no tags. So oops, we can do well, it's tags map string. Let's just call it tags for sorry, I was thinking about should we call it tags or map string function. Let's just call it tags because that's the only thing that uses map string at the moment. Okay, so let's say Marshall tags nil. What happens if it gets a nil? I'm gonna just call it payload because it's the easiest thing to call something that's generic. And JSON. There we go. So Ginkgo has a matcher called match.json. Will actually parse both payloads, make sure that they map to the same JSON. Okay, we're gonna put this next to here. We're gonna load up our favorite thing, which is nope. Why won't this select? There we go. Ginkgo watch -r. We're gonna go here. It's not gonna be able to compile. We're gonna move this over to the right side. Boop 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 boop. Package Marshall func tags, and it takes a map string, and returns a string. And we're going to return empty string for right now. And let's make sure we're doing that at the level. Okay, so I'm going to bring back the code that I already had done right here. I'm just going to get rid of that for a second. Okay, so now we have something passing. Okay, so let's also do it for a payload of Marshall tags that's actually an empty map of a string, which has nothing, and it should return empty. Hey, it's passing. Wait, did I not skip the directory? I did. Is it only running? Oh, it only runs one set of change. I didn't know that. It returns escaped. No, it returns key value pairs as JSON. Okay, so we're going to copy this. We're going to do A1. And we expect that to be A1. Oh no, it did not pass. So we're gonna go back here, do tags equals 0. Boom. Return our constant here. Otherwise, our payload starts with this. We know eventually it will close with that. And then we have to do something with the strings inside. So key value, and we arrange over the tags. I'm not trying to keep any order on these tags too. Sometimes the JSON parser tries to order the tags, the keys in alphabetical order or lexicographical order. Don't care. SQLite doesn't care. I don't care. So, what do we do here? We do payload equals. For now, we can do use sprintf, and this means quote it for us. So it actually puts it in quotes, right? And so we got one. So let's do one with more than one pair. We're gonna do 2 and B here, just so we have something that and it doesn't like that because we don't have a comma here. So how do we do a comma? Well, a comma should only appear after an element as long as it's not the last element, because we can't have trailing commas in JSON, right? So if we do if count is less than the length of tags, payload plus equals comma. I did not like that because for the first one here, -1 because we're 0 indexed. No, it doesn't like that for the next one. Oh, because we have to increment count for each time. Hey. And just be on the safe side. Let's just do one for a third. Just so we have the one-to-many. And it passes. Great. Test coverage for marshalling JSON. So now I should be able to go back here, and instead of using Marshall JSON here, and here, and here. I should be able to go to this and say Marshall tags, object tag, oh, sorry, node tag map. You know what? I think I'm gonna break this down into multiple lines just for the convenience of reading. Yes, I know I can probably use something with a text editor if I was in Vim, do some thing, but I'm just gonna do that. Here. Just to show that I have some cred. Oh no. Hold on. Too far. That's not gonna work just because this is way. And this is gonna be relation. We don't need this up here anymore. And it runs. So if I do remove test.db star, go run star, build OSM. In my downloads, I have this one and db test.db. Is it any faster? No, it's not. It doesn't break anything. Our tests on the right-hand side don't say it breaks anything. Let's make a commit. Custom JSON Marshall for tags. So, what's slowing us down? Well, even though we have a prepared statement, every insert costs us a transaction. And in SQLite, that's just eating us up. So we can do batching. So we can create a transaction that says every n number of inserts, batch them up together. That is an optimization we can do here too. And one that is a well-documented one for SQLite. Like if I search for SQLite insert benchmark, like this is a very well-documented one here. Let's see. Batch inserts. There we go. I tried different sizes of batch inserts, found out 100,000 seems to be a sweet spot. With a simple change, running time was reduced to 10 minutes. So let's try doing a batch insert. So this is a little more work because we actually need to create a transaction for the batch. Keep track of number of inserts. Close that transaction and create a new one. Because as far as I know, you can't reuse transactions. So let's try that out real quick. Let's create a transaction. So we can do client, begin, tx, begin. just begin. Transaction dash error. Oh, sorry, for the sake of doing this, I didn't actually run the linter on the last stuff. Yeah, that's what I thought. Let's fix that real quick. I know I'm running tests in the same spot twice. That's right. Marshall. Yeah. Okay. Okay, so we go back here, create a transaction. And then we're going to say if there's an error, return format could not create a transaction. So, a good practice is with SQLite, with the transaction is to roll it back at the end. The rollback is a no-op if you successfully commit at some point. But you want to roll back no matter what, just in case you want to undo some things that you've been trying to do. So we begin. So our prepare statement actually becomes this transaction prepare. And let's just do one transaction at the moment. And what we're going to say is error transaction commit. If error not equal to nil, return F. Could not commit transaction because of some reason. Okay, let's actually see how fast that is now. I'm actually anticipating it to be quite a bit faster. That is a single transaction. And that's how much faster it processes. Rather than having a transaction for each insert, even if it's a prepared statement, that's how much faster it is. Like, that's orders of magnitude faster. Measurably ordered. We went from 46 kilobits to 4.6 megabytes. Like, I can commit that right now and be happy using transaction increases insert speed by orders of magnitude. Pop. Yeah, yep, I keep forgetting to do that. So this is that linter saying I should check this error. I don't really care about the error of the rollback. Like, by that time, something else has probably happened that has broken. One cuddle. Oh, I can't put that together like that. I need to do that. So, let's amend our last commit. So we just made it orders of magnitude faster. Let's look at our test database, see what we have. I want to turn timer on. Let's look at our schema, right? That's all we got. If I do a select star from entries where no OSM type equals node, let's limit to 1. It has no tags. None of them have any tags. Some of them have tags. Well, that's interesting. Some of these things don't have tags. I'm going to keep that as a note there because if they don't have tags, I don't know what they do. the hierarchy of node to way to relation is that a way can be many nodes, a relation can be many ways and nodes. So these nodes could be associated with a relation or a way. And that metadata is available to us. We haven't inserted it yet. I just wanted to show how to benchmark here and how we can make it faster just with a transaction, as you can see. But I'm going to take a little break here. I'll be back shortly.